Welcome to Alchemy Wizard. I'm Tom. Today we're going to talk about outfitting your first nanoparticle lab. I got a question a week or so ago about a guy who wants to start his own. He wants to start making his own nanoparticles, and he wants to know what can he start with, the minimum that he could start with, in order to get that going. Like everything else, when you start something new, you're on a budget and you don't have a lot of money to expend. So I want to cover some of the basic and maybe some advanced stuff that you might want to get, or at least focus on getting, to start doing nanoparticles. Now, basically, all your nanoparticle stuff begins with beakers. I use a 600 milliliter beaker or 500 milliliter beaker, and I use a 900 or 1000 milliliter beaker. Those are the two beakers I use the most for making the colloidals. And we won't be discussing the metals specifically here, except where, as far as difficulty goes, and the more equipment you need for other metals. So you need beakers. Now, I like these little 50 milliliter beakers for putting samples in and observing samples. You might want to think about those, but there are other size beakers, all different size beakers. And there are these plastic beakers, which are handy for mixing things. You can't use them to make your colloidal nanoparticles in, but they're handy for mixing stuff or temporarily storing fluid if you're short on beakers and you need to put stuff temporarily in a plastic container. And they're all different. This comes as a kit. They're all different sizes, and some of the kits come with graduated cylinders. Again, these plastic graduated cylinders you really can't use them for measurement or anything like that. Just more for pouring things in and storing them. Now, I also would recommend, before we move on, as far as this is a beaker category too, this is a 100 milliliter graduated cylinder. Graduated cylinders are accurate. Beaker amounts are not. I'm not sure why the industry cannot get beaker amounts exact, but they don't. So if you need to measure something specifically, you're going to need graduated cylinders. I use a 100 milliliter cylinder and I use a 10 milliliter cylinder. Those are the two that I use for mixing my chemicals up and that I need, and if I need specific amounts of fluid. So that is something I also would recommend for the beginning laboratory. Pipettes. This is a pipette. Use it to extract fluid from stuff and move it around. It also has a drip feature, which is nice. If you want to use a drip feature, you usually can get a whole bunch of these really cheap, 50 or 100 at a time. They're supposed to be disposable. You're supposed to use a pipette once and that's it, then throw it away. To me, I find that extremely wasteful, especially since we're not dealing with very strong acids or bases or anything like that. So I clean these with RO water or distilled water, and I reuse them. Now, doing your own water brings up another question. I'll show you a picture. I have a distiller here that I use at home. You can buy distilled water. That works too. It's cheaper to make your own distilled water, but if you're going to be turning over colloidals rather quickly, you may want to distill your own water. That's up to you. Either one works. But you must have distilled water for your colloidal use. And I have some videos on distilled water that you can review. I'll put links in the description when I talk about distilled waters and distilling water and things you should and shouldn't do with distilled water. So I'll add that. What are we're coming to the mechanical things? Funnels. You're going to need some funnels. So you might want to pick up a kit of all different size funnels. You're also going to need filter material. I have two kinds of things I use for filter material. I have these small K-cup filters. So after you're done making your colloidal, you have to filter it. You can't drink, there might be debris in there, or you need to filter out the solids. So I'll use one of these funnels, put the K-cup filter in there, and pour it through here. That's one of the things I do with filters. And the other thing I do with filters, if I want to filter a whole lot more, is this setup over here. I have this is a regular coffee filter, and this is a coffee from a coffee machine. And I take the filter, stick it in here, and I put it on top of a jar. This happens to be a mason jar, and I will pour the colloidal out of the beaker and into here. Goes through the filter, gets filtered into the bottom of this mason jar here, and it's filtered. Now, storage of colloidals. How you store your colloidals, that's a personal thing. Some people want to store it in glass. Some people want to store it in plastic. You can use anything you want to store your colloidals in. They don't really care one way or another. It depends on what you feel. These are Nalgene bottles, chemistry bottles. That's what I use here. They're not cheap. They're rather expensive. I think this is a 125 milliliter. This is a 500, and this is a 1,000 milliliter. And I use these for storing my colloidals. Also for storing some of my chemicals that we make, like the sodium citrate and the NaCl stock solution of sea salt. So I use those for that. But any kind of glass jars you can use. You can even use mason jars. I don't particularly care for the mason jars because they tend to leak. And the metal tops, if they're metal, they tend to rust. So I try to stay away from my stuff anyway, from mason jars. But at one time I did use mason jars. Instead, I wanted to do all glass, so I used mason jars to store everything in, and it just didn't work. The next thing you're going to need is a stirrer. Now this right here is just a regular magnetic stirrer. It doesn't have a heater in it or anything like that. If you're just starting out, you're probably going to be starting out. Copper would be the next easiest metal to begin to move on to. I have videos on both of those. But you need a stirrer to keep the water moving so that the nanoparticles will form properly. You can use air bubbles. In the beginning, I had a mason jar. It was a little smaller than this mason jar. I'll show you the little bubble thing going to move the water around. You can start like that. That's fine. But this is more on how do you set up a laboratory sort of thing than how to just get started with colloidals in general. Now, if you want to do gold or you want to stir, you're going to need a heated stirrer. And that's going to be a little bit more money. This stirrer over here has a temperature probe on it for maintaining the temperature in it. It's not a cheap stirrer. It's an expensive stirrer. I started out with a $36 stirrer. It was a heated stirrer. I no longer have it anymore because it kind of burnt out. But it did last for, I guess, about almost a year. A heated stirrer, get one with a adjustable temperature knob on it, so you can control the temperature a little bit. You won't know what the temperature is in the beaker, so you'll need something else to do that because the inexpensive stirrers with heater don't have temperature probes. What you can use, and I would recommend you get this also, is a infrared temperature laser. This is a red laser temperature gun pointed at anything, and it will tell you the temperature either in C or Fahrenheit of what you have. And it's very good if you're heating stuff. You can point this right through the glass, right at the glass like this, and it'll instantly tell you what that fluid is, temperature that it's sitting at. What you're also going to need this for is for highlighting the nanoparticles in the solution. So if you take the laser and go like this, it will start to highlight the nanoparticles as they start growing in your solution. I'll show you a picture of what that looks like. So I would recommend this red laser with the temperature thing for measuring temperatures, and I also would recommend a green pointer laser so that you'll get a better idea of how much colloidals are in it with the green pointer laser. It's much stronger, reflects more light, and you can see the particles more clearly, where you'll get to figure out how much colloidals you have in there by using the laser. Because in a basic setup, you're not going to have a scale. Over here is my scale, and they're expensive. Although the 3-digit scales, 3 decimal place scales, are inexpensive, are coming down in price. A 2-digit scale is not going to work. So what we need is some kind of scale. You might need. Okay, not for the basic setup. Okay, the laser will do the trick for the basic setup. But if you're interested in measuring the amount of material that you've used off of the metals, you need a scale sensitive enough to measure that. So you need either a 3 decimal place scale or 4 decimal place scale. The 2-place kitchen scale, you're going to need that also to measure the powders, like the sodium citrate and the citric acid that you might use if you get more into creating nanoparticles down the road. I have a video on this. TDS meters do not work with colloidals. You might get some idea that you got colloidals going in there, but for the most part, the only thing you're going to be measuring is the conductivity of the solution. You're not going to get away with that with copper or gold or zinc or any of the other more metals. This TDS meter is going to fail big time. You'll think you have all of these colloidals in there, and all it's measuring is the ionic content or oxidizing content that's in the solution, and not the nanoparticles. The laser really is the only way to see these particles and to know how much you got in there. So don't rely on TDS meters. The only thing good a TDS meter is for is measuring your distilled water to make sure it's 0 parts per million. You can't really use RO water. You don't want to cook your colloidals with RO water. You really want to cook them with distilled water, because this thing called coordination complexes, and that's the interaction of minerals with your nanoparticle process. Some strange things can happen, and tap water contains a lot of minerals and stuff, and even at 8 parts per million RO water is still enough to throw off your colloidal stuff. RO water is perfectly good for cleaning your stuff. That's what I use RO water mainly to clean the beakers. That's again an extra expense. RO water setup is going to cost down the line for cleaning and washing the various beakers out, because nothing cleans a beaker better than some RO water and some Dirty Labs dishwashing detergent without scent. I mean, this stuff has to be cleaned, and you could use Dawn dishwashing detergent, but like with plasma arc, it doesn't make a big difference with low voltage DC electrolysis, but with plasma arc, that scent stays on the glass from like Dawn dishwashing detergent, and it's a problem. So I use unscented dishwashing detergent to clean my beakers. Just put a little bit in there. I mean, one thing of it will last a long time, and then just swirl it around and clean it till it's squeaky clean. You go like this and your finger squeaks on the glass, then you know you got all the soap out and everything like that. Because cleaning beakers and stuff is kind of important. The next thing you're going to need is some kind of a power supply. It's out of the camera now, but that's my power supply. That's lab quality power supply. But you can get by with a little brick power supply. I'll show you a picture of that too. For starting out. For platinum, you're going to need a bigger power supply. You might get away with the brick power supply for gold. For platinum, you're definitely going to need the big power supply, because you're going to need current limiting capabilities for that. And of course, I'll have links for all of this stuff in the link section of the website. And I think I've covered just about everything I needed to cover for a basic laboratory. I'm Tom, Alchemy Wizard. I hope you found this informative. I will talk to you guys later.